I also explained about scalar multiplication of vectors. This is a scalar multiplication of this. So that's still minus 1, 1. Plus scalar multiplication means you multiply every single element of that vector or matrix. So this is 2 and 2. We look at these lines separately. I wish I had a big whiteboard, but so minus 1 plus 2 is 1, and 1 plus 2 is 3. Sorry, give me a second. So there's our solution. Yes? So it's 2 times 1, which is 2 here, and 2 times 1 here, it's 2. I multiplied out because it's a scalar multiplication. Do you see that now, or should I write it clear?
Yeah, I didn't see the 2 at first.
Yeah, okay. It's kind of tough holding it with one hand and writing, but okay. So that's as far as it goes for the column pictures. You get the same exact solution, but the different approaches, different ways of getting it. Okay, so now that we spoke about vectors, we want to speak about matrices eventually. That's our end goal, because vectors are nice, but when you deal with matrices, you have more information, so you're tackling a bigger problem at once. Do most people know what a matrix is, or no? Okay. Do people know what a vector is, for those who weren't here yesterday? No? What? Yeah. So as I explained last week, I'm just going to excuse me guys. So again, I have x. So I have 2x plus 2y equals 1, and 1x plus 1y equals 3. 2x plus 2y equals 1, and 1x plus 1y equals 3. They're consistent, because if I multiply this by 2, it says 2x plus 2y equals 6. Oh wait, they're not consistent, right? That should be a 2. That should be a half. Let me make it simple. Whatever. Okay. So it's 2x plus 2y equals 2, and 1x plus 1y equals 1. So I also explained about consistency. And here, if I multiplied this by 2, the whole thing, it gives me the same as this. So that means these two equations are consistent. This is just for a little more information. Okay. So we could, these are your variables, the x and your y's here in my case. A vector is a representation of how to write these equations. Okay? So I could do 2, 1 times x plus y times 2, 1. See here? This is a vector notation. This is it has multiple entries into it. So it's like it's expressing the coefficients. What comes in front of the variable, they're called coefficients. And so we put in a vector notation. Okay?
So x is a scalar, x is a coefficient, and 2 and 1 direction?
No. These are your coefficients, but I'm writing this in a different notation. So this is...
No, then you're writing in that...
No. The x is always a variable.
Oh, okay.
And your y is always a variable. But this is now a vector. Okay?
Wait.
Yes? So what we have for simplicity and not writing the equations down all the time, we could write this into a matrix. So let's say x plus 2y equals 1, and we have x plus 3y equals 7. I'm just making these up. So if you look at the notation there, it says a11x1 plus a12x2 equals b. Okay? The a's represent scalars. coefficients. These are not changing. The x's represent the variables, things that could change. They could take different values depending what your solution is. So right here, this would be my A11 is what's under here, which is a 1. It wasn't written, but it's known that it's a 1. Here, in this case, my A12 is 2. So if I want to write a matrix for this, I write it like this. 1, 1, 2, 3. And then we have to multiply by this xy to be consistent, because, well, later on when we go into multiplication, this times this plus this times this gives you an answer. So in our case it's 1, 7. Okay, that's the thing with matrices. If this equation was on top, it basically means I change the order of how the equations are. It doesn't change the answer. Because instead of 1, 2, 1, 3 times xy equals 1 over 7, it will be 1, 3, 1, 2, xy equals 7 over 1. Because this also changes. So the order does not matter. Okay?
But how about if one of the numbers on the left wasn't actually a 1? Let's say if the top one was a 2 and the other one was a 1.
Okay. So we'll get to that later, but in general, I'm just writing the coefficient. So if this was a 7, this would be a 7. That's perfectly acceptable too. It doesn't have to be a leading one when writing the matrix out. Let's not have a leading one. Let's have x, 7x plus 0y plus 1z, and then we have 1x plus 2y, and then we have just z equals to 1, equals to 2, equals to 3. I'm just making these values up. So it might look a little confusing here because it's not in the exact representation we want.
Is that 10 or 0?
This one?
Yeah.
That's a 0. Okay? I guess now I'll write 0 by this circle with a slash through it, so we don't get confused. So here, let's write this a little nicer so we're a little more familiar. We could do a plus 0z. Oops, that looks like a 7. Equals 2, and we could do 0x plus 0y plus z equals 3. So anyone have a clue how the coefficient matrix is going to look?
0, 1.
Okay.
1.
Here.
2, 0, 0,
1. 0, 0, 1. Yeah. Yeah, we want our coefficient. So this is how our coefficient matrix is going to look.